Conor, we're here at Inlet in Milan, and in your session yesterday you were talking about analog devices and its relevance today in the grid. Can you explain?
Yes, thanks very much, Kevin. Analog Devices as a company is a semiconductor company, and a lot of people don't actually make the connection between semiconductors and the relevance to the grid. So in my speech yesterday I was talking about how Analog Devices up to now, maybe the last 5 years, has sold about 1 billion devices, as in semiconductors, to grid applications. And these include the type of grid applications in things like clean energy infrastructure, so including renewable energy generation like solar and wind, in areas of battery storage, energy storage on the grid, and in EV chargers. In other areas then, there's our business we have, a big business in metering, where we do a lot in smart meters, and also we look at power quality. Power quality meters is a new thing, specifically with the onboarding of renewables. It's becoming a much major topic, both from a grid perspective and from a perspective of the actual in-facility perspective as well, as it gets down to the factory. So that's a very interesting thing. A little factoid I said actually on the stand was that in Analog Devices, in 1999 we were the first company, which is a little known fact, that we actually introduced the first smart meter, or first meter front end, analog front end, integrated front end for the whole industry. So that's why we've been in that business for such a long time. And then finally we do some business, a lot of business in fact, on transmission and distribution grid. So things like switchgear, circuit breakers, protection relays, transformer terminal units, anything where it really requires a high degree of wideband, high precision conversion from the edge to digitalization.
And from being here for the 3 days, any thoughts on, you guys have some focus areas for growth in the future, and any thoughts on where you're seeing growth?
Yeah, some of the real growth areas are actually on the DERs. It's the distributed energy resources and the loads, particularly around the whole thing of batteries. I mean, batteries is booming. It's also booming in mobility, but it's also booming in storage, because as we onboard those renewables and as we do more and more of that, we need the batteries to provide the services that are required to keep the grid going. So a lot of people talking yesterday about demand response services, energy management, and these people actually wouldn't have businesses without the batteries, which are actually providing all these, the backups and the load leveling and the peak shifting and all these types of services that are required to be able to shift the energy to at the correct time of when the customer needs it. Another thing as well we would look at is the area of power quality, as I mentioned already. Behind me actually here we have, we're looking today about our new Class S power quality measurement solution, whereby we can take in the harmonic detail, or we can take in the detail of the signal and look at the harmonic output, and we can look at what it looks like and then digitize it, and then compare that to a library of SClass functions based on an IEC standard, and deliver that directly a report to the customer. So they don't really have to do it themselves. So it's a really, really outstanding sort of technology. But as I said, the power quality is going to become very, very important in the future, because as we onboard renewables, the quality of the power is going to go down, and that can have a significant input into things like the energy efficiency that we're delivering to the end loads. It can also cause loss and inefficiencies and mechanical faults in the future, and it causes financial loss, which is a very big thing.
No. Certainly the power quality, the rise of batteries are key themes that I've seen here this week. But no, hey, I wish you well. Thank you very much.
Thanks very much, Kevin. Thank you.